Welcome, class! Today we are going to explore the planets in our solar system and some of the weather phenomena they experience. Before we get started, however, let's categorize them. First, we have our inner planets. Inner planets are the 4 planets that are closest to the Sun. This includes Mercury, Venus, Earth, and Mars. The outer planets are the 4 planets that are farthest from the Sun: Jupiter, Saturn, Uranus, and Neptune.
To help you remember this, here is a simple acronym that we learned in class. MVEMJSUN, or My Very Educated Mother Just Served Us Noodles.
Inner planets are also known as terrestrial planets because they have 3 distinct features. They are solid, relatively small, and dense. Like the inner planets, outer planets are also known by another name, Jovian planets, because they also have 3 distinct features. They are large, have many rings and satellites, and are composed primarily of hydrogen and helium gas. These Jovian planets are also named as such because their large size and gaseous composition resemble those of Jupiter. Now that we have a basic understanding of the planets, let's look more closely at the weather they experience. Because there are many planets in our solar system and each has so much of its own weather and characteristics, we have decided to focus on our 4 favorites: Jupiter, Mars, Saturn, and Venus.
When it comes to exploring weather patterns, Jupiter has some of the most extreme. The planet experiences storms that can grow to thousands of kilometers in diameter in the space of a few hours. Like Earth, it experiences windstorms, lightning, and auroras in its northern and southern polar regions. The weather on this planet is so extreme, in fact, that it can even be seen from space. Jupiter is composed primarily of gaseous and liquid matter. It is the largest of the gas giants, and like them, is divided between a gassier outer atmosphere and an interior that is made up of denser materials.
The atmosphere contains about 82% hydrogen, 17% helium, and 1% methane, as well as trace amounts of water vapor, crystals of frozen ammonia, and silicon-based compounds. Jupiter is perpetually covered with clouds that are composed of these ammonia crystals and possibly ammonium hydrosulfide. These clouds are located in the tropopause and are arranged into bands of different latitudes, known as tropical regions. These clouds are also what give the planet its banded appearance, with clouds of yellow, brown, and white circling the surface rapidly. These bands are produced by air flowing in different directions at various latitudes. Lighter hued areas where the atmosphere rises are called zones. Darker regions where air falls are called belts. When these opposing flows interact, storms and turbulence appear. One storm, known as the Great Red Spot, has been raging since at least the late 1600s, when Italian astronomer Giovanni Cassini made the first recorded observation of it. The storm has been shrinking and expanding throughout its history, but in 2012 it was suggested that the giant red spot might eventually disappear. This storm is one of the best known features in the solar system. It is located 22 degrees south of the equator and reaching sizes of up to 40,000 kilometers across. It is larger in diameter than Earth. The storm rotates in a counterclockwise motion, making it an anticyclonic storm. Mars also has crazy weather. This giant planet is a little more than half the size of Earth. It contains polar ice caps, and its seasons are nearly twice that of Earth due to the fact that it takes almost 2 Earth years to orbit the Sun. When it is closest to the Earth, which happens once every 15 to 17 years, its bright, ruddy color outshines the brightest stars. The atmosphere of Mars is very thin and is composed of 95% carbon dioxide, 1.93% argon, and 1.89% nitrogen, along with traces of oxygen and water. Because this Martian atmosphere is so thin, it doesn't trap heat as much as Earth does. The temperatures, therefore, are generally a lot colder than here on Earth, with temperatures ranging from 30 degrees Celsius in the day to negative 130 degrees Celsius at night. That's cold, too cold to sustain life. The atmosphere is also very dusty, containing particles that measure 1.5 micrometers in diameter, which is why the Martian sky has a tawny color to it when seen from the surface. Its thin atmosphere also does not allow for liquid precipitation. This means that solar radiation would cause any liquid water to dissociate into hydrogen and oxygen. This also means that there is not enough precipitation to maintain a water cycle, another major factor in being able to sustain life. Mars is also very similar to Earth in its structure. It contains a dense core which carries iron, nickel, and sulfur. Surrounding the core is a rocky mantle, just as Earth does, and above that a crust made of iron, magnesium, aluminum, calcium, and potassium. Mars does not currently sustain life, but many scientists are hard at work trying to find out more about this giant planet. In 2012, NASA's Curiosity rover landed in Gale Crater and is still reporting findings and samples of the planet. Saturn is almost twice as far from the Sun as Jupiter and only second in size in our solar system, surpassed only by Jupiter but with a much smaller mass. It has a radius of 36,183.7 miles and is 9 times wider than Earth. In other words, if Earth were a nickel, Saturn would be about the size of a volleyball. That's big. Saturn also has a structure similar to Jupiter's, with a dense core of metals consisting of iron and nickel. Surrounding the core is a rocky material as well as other compounds that are solidified by intense pressure and heat. It is then enveloped by liquid metallic hydrogen inside a layer of liquid hydrogen. Believe it or not, Saturn is the only planet in our solar system whose average density is less than water. I know, crazy. Basically, if there were a bathtub big enough, Saturn would float. This planet's atmosphere is a lot like Jupiter's, with hydrogen making up nearly all of it and little amounts of helium, methane, and ammonia making up the rest. It is considerably colder than Jupiter, with an average temperature of about negative 285 degrees Fahrenheit. The wind speeds on this gas giant are extremely high, having been measured at slightly more than 1,000 miles per hour. Saturn also has layers of clouds, just like Jupiter, but the bands on this planet are not as stunning. The stripes found here are wider, especially near the equator. The colder bands where gases rise are known as zones, while gas within the warmer belts falls toward the planets. The planet contains more sulfur than Jupiter, which gives its belts and zones an orange smog-like color. Probably the most amazing part of Saturn are its rings. These rings are thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet due to its powerful gravity. The billions of chunks are made of ice and rock coated with another material, such as dust. The particles range from tiny, dust-sized icy grains to chunks that are as big as houses, some even the size of mountains. Wow, that is almost hard to believe. It is so incredible. The rings also orbit at different speeds around the planet, with the fastest ones occurring closer to the planet and the slower ones farther out. The whole ring system extends up to 175,000 miles from the planet, with the vertical height only being about 30 feet in the main rings. Finally, let's look at Venus, the second planet from the Sun. Venus has a very dense atmosphere and opaque cloud cover that generates high temperatures near 880 degrees Fahrenheit. It is made up of about 96% carbon dioxide, and its clouds contain sulfuric acid droplets. There are many layers in the atmosphere with different temperatures. As the planet moves forward in its solar orbit while slowly rotating backwards on its axis, the top level of clouds zip around the planet every 4 Earth days, primarily driven by hurricane-force winds. These winds travel around 224 miles per hour, and atmospheric lightning bursts light up these quick-moving clouds. Speeds then within the clouds decrease with cloud height, and at the surface are estimated to be just a few miles per hour. From the ground, it would look like a very hazy, overcast day here on Earth. And because the atmosphere is so heavy, it would feel like you were 1 mile deep underwater if you were able to stand on the surface. That's a lot of pressure. Venus is also very similar to Earth in terms of its structure. Like Earth, this planet has an iron core with a hot rocky core that slowly churns due to the planet's interior heat. The surface is a thin crust of rock as the mantle moves and bulges, forming volcanoes. This planet also has mountains, valleys, and tens of thousands of volcanoes. The highest mountain, Maxwell Montes, is 20,000 feet high, similar to our familiar Mount Everest. The planet is also covered in craters, the smallest ones ranging from 0.9 to 1.2 miles across. Because the atmosphere is so dense, small meteoroids just burn up, so only large meteoroids hit the surface and create these craters. And because Venus is so hot, no life could survive there, so please don't try and take a trip there. It will only end badly. As you can see, there are some pretty crazy weather patterns that occur on these planets, and some of them are very similar to those found here on Earth. In lab tomorrow, you all are going to be creating your own unique planets that will show what these weather patterns might look like. This means you need to decide as a group what your planet will look like and what its features will be, such as temperature, weather, and formation, etc. At the end, we will all compare our planets and discuss what each group did.